Okay, hi guys. I am going to go over some notes that you may have missed on the Geometry Lines and Angles packet. So make sure you have this out, and please make sure your name's at the top in case yours goes missing. And I need you to flip open your book to page 7. You might have already done this page, but I just want to go over really quickly what an angle is. So remember that an angle is two rays. So it's formed by two rays that share a common point. And if you don't remember what a point is, you're going to look back here in the beginning, and this would be a great example of a point. These are all points. Those dots are all points. So they come together to make two rays share one point. And I'll show you what that looks like in just a moment. Angles are measured in degrees. Ignore my dog drinking water in the background. They're measured in degrees. If you went all the way around a circle, it would be 360 degrees. And you kind of hear that in sports and maybe even skateboarding. If someone stands in a circle and then, or excuse me, if they stand and then they jump and make a big circle and they land in the same spot, then we call it a 360 degree turn. Okay, same thing. So you have to accept that you can measure a circle. Who knew? And it is 360 degrees all the way around. Okay? Now, when we do that, if we take our 360 degree circle and we divide it into 4 equal parts, then we're saying that there are 4 parts, so 90 times 4 equals 360. Remember we talked about this is a right angle is formed, and really that should be a box, that's your symbol for a right angle. So there are 4 right angles in here, 4 90 degree angles. So because it makes sense, so since 90 times 4 equals 360, it makes sense that it would take 4 90-degree angles to angles to go completely around the circle, okay? So we need to circle all the angles down here. Remember, the angles share a point, so they have to be touching, okay? So let's look at this one. Are these two rays touching? Yes, they are. They're touching right there, so we're going to circle that one, okay? Are these two rays touching? No, they're not, so we're going to leave that one alone. Are these two rays touching? Yes, they are. And when they touch, they kind of form a corner. You'll see that right here. They kind of form a corner. So I want you to think about angles as corners. Right? Now, into the new stuff. There are 3 types of angles. And we're going to go over the first one right now. So with me, you're going to copy these notes. An acute angle. This is how I want you to remember it. It's a cute little angle. Cute little angle. That's why whenever you hear us talking about it, we use like those little funny voices, because I want you to think that is little. It measures, that's a less than sign, less than 90 degrees. So here's a great example of an acute angle. Okay, and I will come back and reference this again here in the right angles. So you need to copy that down. An acute angle measures. So it's a cute little angle and it's less than 90 degrees. Okay. Give me a moment to write that. Okay. A right angle. A right angle measures exactly 90 degrees. Exactly 90 degrees. So whenever you have a right angle, you have a square corner. And the symbol for that is to draw a square right there. Now, we're not all gonna be perfect artists, so forgive me. Okay, do you see how it kind of, like this line is perfectly up and down and this one's perfectly left and right? This one forms, so because of that, it forms a right angle, okay? So when we're comparing a right angle to an acute angle, do you see how it is smaller, they're closer together? That's what makes it acute, or we say a cute little angle. That's why we always talk so silly. It's little, it's a cute little angle, okay? Less than 90 degrees, not 90. 89.9 is still less than 90. So that counts. Obtuse angles. Obtuse angles measure greater than, bigger than 90 degrees. So not 90 degrees, because remember a 90-degree angle is a right angle. That's my cat. Ignore Moxie. That measures, so an obtuse angle measures bigger than 90 degrees. And we always use big, deep voices. We say obtuse angle, because they're really big angles. So trying to do this one hand is hard. Here is an example of an obtuse angle. I have my point right there in the middle. Okay, there we go. That's my example of my obtuse angle. Comparing it to the right, Here is a right angle that measures exactly 90 degrees, no more, no less. This one is open bigger, is open wider than a right angle, so we call this an obtuse angle. Okay. Here are some down here. Look at this one. Does this one look like it's bigger or smaller than a right angle? Okay, it's smaller. So we're going to say that it's acute. So right here in the circle, we're going to write A for acute. I'm going to skip this one and come back to it a little bit later. This is its own special angle right here. This one, well, it's kind of hard to tell. It kind of looks like a right angle, but I'm not sure. And I like to be exact because that's the kind of mathematician I am. So what you're going to do is you're going to take the corner of any sheet of paper that's not been cut, because they are all 90-degree angles. And what you can do is you can line it up. And do you see how that angle, how those two rays line up perfectly with the edge of this paper? That makes this a right angle. The fact that it lines up perfectly makes it a right angle. Compare it to this acute angle. Look what happens. Okay. Can you see that other ray? Can you see that line in there? No. Since it goes inside, that means it's smaller than a right angle. So it's an acute angle. Okay, now look at this one. This one's all crooked. Just because it's crooked and not perfectly up and down does not automatically make it acute or right. So, two things you can do. One, you can turn it to where it looks a little more normal, or you can leave it the way it is and still measure. It does not matter. Make it work. Okay, I'm going to line up my edge of the paper, and do you see how it's perfectly along the edge? So this makes it a right angle. So with me, write the letter R. Look at this one. Okay, it is greater than 90 degrees. Do you see how it goes past my sheet of paper? Since it goes past it, that makes it an obtuse angle. And then what about this one? This one kind of reminds me of my picture that we drew up here. Does it remind you of that? So what would that be? Hopefully you said acute angle, because it is. Now, this guy right here is a little different. This one's called a straight angle. Write that with me, please. Straight angle. It looks just like a line, right? Because there's arrows on the end. But do you see this little half circle right here, this little semicircle? That semicircle tells you that we're looking at angles. Okay? And when you have an angle that is flat, it measures exactly, so let's see if we can find some room. Here we go. Exactly 180 degrees. You have to know that. It measures exactly 180 degrees, which if you look over here at this circle on the previous page, if I was to draw, let me draw it. If I was to draw a straight angle, there you go. If I was to draw a straight angle, you'll notice that I've formed a right angle. Look here. Here's one right angle. Here's one right angle. And what is 90 plus 90? What is 90 plus 90? Let's look. 90 plus 90. 0 plus 0 is 0. 9 plus 9 is 18. And look what we have. 180. That's because a flat angle or a straight angle is 180 degrees. It's half of a circle. A circle, full circle is what? 360? Well, guess what 360 divided by 2 is when you're cutting it in half? 180. So this is a straight angle. You need to know what kind of angle this is because you're getting ready to take a daily grade over this. So over here, because it is bigger than a right angle, it's a very specific type of obtuse angle. So we're still going to label it as obtuse. Okay. All right. Now, just like lines, excuse me, just like lines, remember how we gave lines names over here? We said this was, let's see, where were we? This was line SU, because these are the outer points. Okay. We do the same thing for angles. We have to name our angles. When we do that, what we have to do is we have to name it going from one end to the middle to the other end. And every time we name it, the middle point, that vertex, is always in the middle. So this part right here, I'm going to highlight it, or I'm going to circle it with my pen. This angle right here, we would name it angle A, B, C. And B has to be in the middle because it's the vertex. I could also name it angle C, B, A. Going backwards, C, B, A. But just keep in mind the vertex, the middle, the point has to be in the middle when you name it. Otherwise, it does not matter which way you choose to do the AC or the CA. But as you know, I like to do things left to right because that makes most sense to me. So that's what I did, A, B, C. That's what I would do. Okay? So what we're going to do on this one is we're going to talk about what is the measure. Now, we're going to get to exactness. In fact, you've already learned about exactness today using protractors. So we're taking a step back, and we're just going to label them as acute, right, or obtuse. So we're looking at angle ABD. Here is angle ABD. ABD. So this big old angle here, we're ignoring ray BC right now. Let's look. Get my sheet of paper. I'm not sure. Okay. What do you notice about angle ABD? It is 90 degrees. So angle ABD is a right angle. A right angle.